Question number 4 now from 13.1. A cubical block of size 7 centimeter is surmounted by a hemisphere. What is the greatest diameter the hemisphere can have? And you also have to then find the surface area of this solid. So somewhat like this we can visualize that this is a cubical box, means all its length, breadth, height will be 7 each as per given. And then इसके ऊपर एक हेमिस्फेयर है. Okay, it has been surmounted by a hemisphere. Now the greatest hemisphere that you can fit in would have the diameter same as the edge. जितना इसका edge है उतना बड़ा आप इसमें hemisphere surmount कर सकते हो. Like I've shown you this, the top of this box. The top of this box, then the maximum, because the base of this hemisphere would be circular. Right, base of hemisphere is always circular, so the maximum circle that can be adjusted here would be having the diameter same as the edge of the cube, that is 7 centimeter. ठीक है, so radius would become 7/2 then naturally, okay, of this hemisphere. So ऐसा कुछ structure है. So the greatest diameter, as I've told you, of this hemisphere is 7 centimeter possible, which is same as the whatever will be the side of the cube, उतना उसका maximum diameter का हम उसमें circle या hemisphere fit कर सकते हैं. Then you have to find the surface area of this solid. Now surface area, as I've told you, surface area is whatever is visible to us, what we can touch and feel. Okay, so when you're seeing this figure, suppose ये solid मैं आपको दे दूँ, so what all will you be able to see? You'll be able to see the 4 walls here, 1 2 3 4 walls. You'll be able to see this base. Then इस टॉप में आपको ये पोर्शंस दिखेंगे यहाँ पे के 1 2 3 4 लेफ्ट ओवर पोर्शंस 1 2 3 4, क्योंकि ये सर्कुलर पोर्शन के ऊपर तो हेमिस्फेयर आ जाएगा, तो फिर ये हेमिस्फेयर का CSA आपको दिखेगा. Okay, so what all can we see or what all will be included in the surface area is the 4 walls and the base, and top पूरा नहीं आएगा, इससे ये सर्कुलर पोर्शन हट जाएगा, right, because इसके ऊपर हेमिस्फेयर आ गया है. Right, so that is why we are saying that surface area of this solid would be, we have taken TSA of cube. TSA में 4 walls top as well as bottom आ जाता है. उस TSA से मैं माइनस कर दे रही हूँ एरिया ऑफ दिस सर्कल, क्योंकि ये सर्कुलर पोर्शन आपको नहीं दिख पाएगा, इसके ऊपर हेमिस्फेयर आ जाएगा, तो हेमिस्फेयर का CSA आ जाएगा. Okay, so surface area of the solid will include TSA of the cube, CSA of hemisphere, and you'll have to minus this circular portion. This is not visible. So we know TSA of cube is 6a square, CSA of hemisphere is 2 pi r square, and area of the circle is pi r square. ये r दोनों का same है, इस circular portion का hemisphere का, so we can put it together, like terms हो गए. We can write it as 6a square, and this becomes plus pi r square. Putting the values, 6a is 7 square हो गया, pi is 22.7, r will become 7/2, radius diameter हमने 7 बोला है maximum, तो half of that. Calculate. This would be the surface area of this solid obtained. Alright, तो आपको थोड़ा visualize करना है कि वो क्या कह रहा है, ये कैसा figure है, मुझे क्या क्या दिख रहा है. Just need to think it that way. Okay, now the fifth one question. A hemispherical depression is cut out from one face of cubical wooden block such that the diameter L of the hemisphere is equal to the edge. Again means maximum जितना मैं निकाल सकती थी. Okay, just now like in the earlier question, whatever is the diameter of the hemisphere is same as the edge of the cube. Then you have to determine the surface area of the remaining solid. Okay, so somewhat same चीज हो रही है इसमें, little bit differences there of course. You have this cubical block again, and इससे आप ये maximum circular boundary से अपना अंदर एक cavity dig in कर रहे हो. Okay, depression means depression is something lower than the nearby areas, depressed, नीचे. Okay, so depression उसमें surmounted था, ऊपर आ रहा था. See in the previous figure हेमिस्फेयर ऊपर आ रहा था, इसमें एक हेमिस्फेरिकल कैविटी चली गई है, अंदर डिप्रेशन चला गया. ओके, you've taken out all this material from here. Okay, but whatever the case, surface area जब आप देखोगे तो again it's same as the previous one. Why? Because 4 walls आपको दिखेंगी, base दिखेगा, top दिखेगा, but पूरा नहीं दिखेगा. यहाँ पे आपका space हो गया है, ये आपने हटा दिया है, तो this circular portion again has been to be removed. एंड उसकी जगह आपको CSA ऑफ द हेमिस्फेयर, अंदर देखोगे तो CSA ऑफ द हेमिस्फेयर दिखेगा if you peep in, right? So surface area of this remaining solid will once again include TSA of the cone. I don't know why I have written cone, it is cube. Okay, TSA of cube minus area of circle, ये वाला पोर्शन हट गया है क्योंकि के, एंड CSA ऑफ हेमिस्फेयर एग्जैक्टली सेम. उसमें ऊपर से दिख रहा था हमको हेमिस्फेरिकल, यहाँ अंदर से दिखेगा हेमिस्फेरिकल. Okay, but calculation wise formula will come out to be the same. Okay, so 6a square again plus 2 pi r minus pi r, that makes it 6a square pi r square, and this time the edge is given to you as L. Okay, so वहाँ 7 था, यहाँ पे L रख दो. 6L square pi L by 2 radius square, so that becomes L square. 2 का square 4 comes in denominator. I have taken L square was present in both, common कर दिया denominator, L square by 4 common ले लिया है, so this increases 4 6 are 24 times, L square common ले लिया था और यहाँ से 4 and L square पूरा common गया है तो pi remains. This would be the expression for surface area of the remaining solid. Now, sixth question says, we have a medicine capsule which is in the shape of a cylinder with two hemispheres stuck to each of its end, like this. Okay, this is a capsule they are talking about. Jiska the entire length is given to you as 14 and its width, diameter, length along this, whichever way you say, is 5 millimeter. Then you have to find the surface area of this. So as I've shown this figure here, तो इसका जो ये इन बिटवीन पोर्शन है ये सिलेंड्रिकल है एंड ये इसके टू एंड्स में हेमिस्फेयर है. वन हेमिस्फेयर इन दिस एंड ऑफ द सिलेंडर, वन हेमिस्फेयर इन दिस एंड. तो ऐसे बना है आपका कैप्सूल विच इज 14 मिलीमीटर लॉन्ग एंड द डायमीटर वाज 5 मिलीमीटर. सो ये जो हेमिस्फेयर का रेडियस होगा वो 5/2 हो जाएगा. सो 5/2 दिस साइड, 5/2 this side gone. From 14, so 5/2 plus 5/2, that is 5 total. So from 14 minus 5, तो cylinder का जो in between height of the cylinder आएगी, that will come out to be 9 mm. Okay, that is what you have to calculate and understand. Rest is easy. What can we see? We can see the CSA of cylindrical portion and also the CSA of two hemispheres. Hence, the surface area of this capsule has CSA of cylinder, the round portion, and two hemispheres. CSA, of course, CSA of two hemisphere. So CSA of cylinder is 2 pi r h, 2 into 2 pi r square, that becomes 4 pi r square, या whatever. Radius दोनों का same है, cylinder as well as hemisphere. So again we can take common. 2 pi यहाँ भी है, 2 pi यहाँ भी है, r can be taken common. So 2 pi r I have taken common. What remains here is only h, and from here 1 2 and 1 r remains. 2r is same as d, diameter, which was 5. So put those values. 2r diameter was 5. H of the cylinder अभी हमने workout कर लिया, यहाँ से हिसाब लगा लिया, that is 9, and r is 5/2. Put the values, do your calculation and get your solution. Okay, so just visualize all these and rest is all your formulas and calculations.